Hello everyone, welcome to the next part of the chapter Electric Charges and Fields. So now the next topic is the forces between multiple electric charges or the superposition principle. So the first topic is a superposition principle when there are a large number of the electric charges. So according to this principle, total force acting on a given charge due to the number of charges around it is the vector sum of the individual forces acting on that charge due to all the charges. So we are going to understand by considering an example. As shown in the figure, let there are the three charges and this is known as the system of three charges. These charges are Q1, Q2 and Q3 and they have their position vectors like R1, R2 and R3. We can also apply this concept for the system of n charges, but for the simplicity and the basic understanding of the concept, we are going to take the system of the three charges. So we can suppose that in the diagram Q1 is the charge which is surrounded by the charge Q2 and the Q3. So now we are going to calculate the total force that is acting on the charge Q1. So here the forces F13 and the forces F12 are acting on the charge Q1. We can suppose that the force F13 is the force due to the charge Q3 on the charge Q1 and the force F12 is due to the charge Q2 on the charge Q1. So we can apply the Coulomb's law and find the result for the force F12, that is equal to 1 upon 4 pi epsilon naught. Coulomb's law is the rule for the two system of the charges, not more than the two. So F12 is a force that is acting on the Q1 charge due to Q2. So this is equal to 1 upon 4 pi epsilon naught Q1 Q2 divide by R12 square. So we can clearly see in the figure the distance between Q2 and Q1 is R12 and along with that R cap 12 is written. R cap 12 is specifying the unit vector or the direction of the force. Then the force F13. The force F13 is force on the charge Q1 due to the charge Q3. So again we apply the Coulomb's law. So this is equal to 1 upon 4 pi epsilon naught. Now the involvement of the charges Q1, Q3 divide by R13 square R cap 13. So now using the principle of superposition, we can find the vector sum. So the complete force by using the parallelogram law, we get the resultant force is F1. So F1 is equal to F12 plus F13. By taking the 1 by 4 pi epsilon naught common, we get the final answer. We can also apply this concept for the case of the n charges when there are the large number of the charges surrounding the charge Q1. So we can change the result as Qi divided by 4 pi epsilon naught into summation of Qi divided by distance multiplied by the unit vector that show the direction of the total force acting on the given charge. Here is the importance of superposition principle, that we can apply Coulomb's law to any collection of point charges by using this principle. Here is a word closely spaced electric charges. Closely spaced electric charges means there is a large amount of the charges which are placed very close to each other that they can't able to express their effect individually. They can only study in their collection or in a continuous pattern. For such cases, we study about the continuous charge distribution. So it is a system of closely spaced electric charges that form a continuous charge distribution. At macroscopic scale, the number of charges is very large. practically at this level, it is required to count the number of charges, so quantization of charges can be easily ignored. In other words, it can be said that at macroscopic level, the charges can take continuous value. So, continuous charge distribution can be on a line on a surface on the entire volume. To calculate the force due to continuous charge distribution on the test charge, the concept of charge density is introduced. So as I said earlier, continuous charge distribution can be on a line, on a surface, or on the entire volume. So in this concept, we are going to understand about the linear charge density when the continuous charge distribution is on a line, surface charge density when the continuous charge distribution is on a surface, and the last is a volume charge density. Linear charge density. It is denoted by a symbol lambda. It is defined as the charge per unit length. If a charge capital Q is uniformly distributed along a line of length L, then the lambda is defined as Q divided by L. The SI unit of lambda is Coulomb per meter. The next one is a surface charge density. It is defined as charge per unit area. If a charge Q is uniformly distributed on a surface of area S, then sigma, that is a surface charge density, is defined as Q divided by S. SI unit for sigma is Coulomb per meter square. The third one is a volume charge density. It is denoted by the symbol rho. It is defined as charge per unit volume. Mathematically, it is defined as Q divided by V. Its SI units are Coulomb per meter cube. Now, in a case, if the charge is non-uniformly distributed over a line or a surface or a volume, then the line or surface or volume is assumed to be consist of small elements. The charge on small length element, that is dl, of line having linear charge density is defined by dq is equal to lambda into dl, whereas the charge on a small surface area element ds of a surface having surface charge density, then it is defined as dq is equal to sigma into ds. Here lambda is called as the linear charge density and sigma is the surface charge density. Then again for the volume, dq is equal to rho into dv. Here dv represent the small volume element. So here first question in this lecture is, a polythene piece rubbed with a wool is found to have a negative charge. Estimate the number of electrons transferred. Polythene piece is having a negative charge, so the wool is having a positively charged. So we can say that few amount of electrons are transferred from wool to polythene. Next question is, why can one ignore the quantization of electric charge when dealing with macroscopic, that is large scale charge? When dealing with macroscopic or large scale charges, the charges used are huge in number as compared to the magnitude of electric charge. Hence, quantization of electric charge is of no use on a macroscopic scale. Therefore, it is ignored and consider that electric charge is continuous. So thank you for watching this video. Hope you like it. Take care. Have a nice day.